Before we start this video, a large thank you to Basna, Alejandro, Liptalk, Raul Vengas, and Andrew Ridgway. Thank you guys so much for your support, and I hope you enjoy the video. Hello guys, in today's video we're going to make our enemy move after our target and chase us, and then stop when he gets within a very close distance of us. So, let's open up our enemy Locomotion Manager. And I'm doing a lot of stuff here kind of fast, and at first it might not make sense, but it will make sense at the end of the video, I promise. Just follow along if you don't know what's happening. A lot of you will probably get what I'm doing. So, first let's make a public void, and I'm just going to call this handle move to target. And open up those curly braces there. Now, we're going to say vector 3. I'm going to say target direction is equal to our current target dot transform dot position minus our transform dot position. So pretty straightforward. We're just looking for the direction that our target's in. Okay, next, right below that, we're going to say float viewable angle is equal to vector 3 dot angle between our target direction and then our transform dot forward. So much like what we did in our handle detection, we're just getting the angle between us looking and where our target is. Alright, so then we're going to say if enemy manager dot is performing action. I think that's privated. Yeah, okay, make that public. So this is for the next video when we handle our basic attacking. We're going to say if enemy manager dot is performing action. So if the enemy's attacking or rolling, then we want to do some logic here, and by that I mean we're going to want to make our movement 0. Let's also make an enemy animator manager or animator handler. I forget what I called it, but I'm going to call it manager for now. Now we actually don't have the script yet, so we're going to quickly make an enemy animator manager, and then we're going to make it derive from another base class called Animator Manager, and we're also going to make our player's animator manager or animator handler, whatever I called it, derived from this base class too. Because like I said in the last video, we're going to make our AI work very similar to the way our player works. So in manager terms, make animator manager, and I'm going to open that up. I'm going to add my namespace up here, SG, as is per tradition. Sorry if I sound a bit nasally, guys. I got a bit of a stuffy nose today and yesterday. Next, I'm going to make my namespace up here in enemy animator manager, and I'm just going to make this derive from animator manager. There we go. I'm going to erase the start and update methods. Don't worry, this will all make sense momentarily. Okay, save that. Now I'm going to open my player's animator. What did I call that? I believe. Get my projects mixed up here. Animator handler. Okay, yeah, so I did call it animator handler. You can rename it if you want. I'm not going to bother. I'm going to make this derive from the animator manager, and I'm going to assign the play target animation function. It's going to copy this here and then erase it from here, and I'm going to paste it in the animator manager. So that class can still use it, but now the enemy animator manager can also use the same function. We're also going to need to take the animator variable here because it's giving us an error. That's okay. So just going to take the animator variable here. Excuse me for that cough, and place that right there, and we should be good to go. Yeah, we are. Next, let's go check here now, see if we need to take anything else. We're going to need to make an on animator move statement, but we're going to make ours a bit different on the enemy animator manager, so we'll leave that for now. Okay, let's save that. Cool. Now we actually have to assign the enemy animator manager on our player's model, or enemy's model rather. So let's go here, right where the animator is. Say enemy animator manager. Excellent. Okay, so let's go into AI, and we'll go to enemy manager, open that up, and enemy locomotion manager. So down here in move to target now, we're actually going to call that on awake first. So let's say enemy animator manager equals get component in children, because it is sitting on the game object below this one, next to the animator. Okay, cool. So now what we're going to do is, if we are performing action, then we don't want any movement, because that means we're attacking or something. So we're going to say enemy animator manager.anim set float vertical, because this is what controls our movement, and we're going to set that to 0. over a time of 0.1 seconds by time.delta time. Okay, so if we are performing action, this will make our movement 0. And then we're going to say Animator Manager. Do we have a nav mesh agent yet? No, we don't, I don't think. Let me check. Okay, so we're just going to say using UnityEngine.ai. Sorry for all the coughing, guys. Let's see here. Nav mesh agent. Nav mesh agent. I have to make one of these two. So we're going to actually use a combination for our movement of both nav mesh and root motion with no nav mesh. And you're thinking to yourself, what the fuck? But don't worry, it's going to make sense. We're going to say nav mesh agent equals get component in children nav mesh agent. So basically the idea is that when we're actually attacking or moving, we're using our root motion and not our nav mesh agent, so it looks more natural. It has a nice flowy movement. We're going to say nav mesh.enable equals false. But when we're actually rotating, we're going to follow the nav mesh's rotation so we can actually have some pathfinding. And I'll show you what I mean momentarily. So if we are performing an action, we're going to want to say stop our movement here. So that's why vertical is being assigned 0. Else we are not performing action. We're going to say if Animator Manager, actually, didn't mean to do that. Let's just say if distance from target, which we don't make yet, is greater than stopping distance. Open up some curly bracers, and then we'll say Animator Manager.anim.setFloat vertical, and we're going to set that to 1 over a time of 0.1 f over time.delta time. Okay, so then we're going to say up here, public float distance from target and public float stopping distance. So distance from target will be how far away we are from our current target, and stopping distance will be the minimum distance away we need to be before we stop running at him like a maniac. So we're going to say distance from target is equal to vector3.distance, how convenient, between our current target .transform.position and this transform.position. There we go. Wonderful. Very simple. Okay. That looks good. I'm pleased with that. All right. Back up here, moving along swimmingly. We are going to say stopping distance equals 0.5 f. I may change that. I think 1 will actually be a better number. I'm probably going to change it to 1. Now, let's make our nav mesh agent. So let's make an empty game object here. It's important that it sits under the Locomotion script and the regular enemy game object. Let's make a nav mesh agent. I'm going to make the stopping distance 0.5. Not that that matters because we're going to be stopping manually most of the time. So we're back in the enemy manager here. We're actually going to come in here on fixed update, and I'm going to put our handle current action on that because a rigid body moves better on fixed update, and it also is less memory intensive to run all of our actions on fixed update. So then we're going to say down here under handle current action, if we do have a target, we're going to say enemy locomotion manager move towards that target. Very straightforward. Okay. Down here we're going to say enemy locomotion manager dot nav mesh. Actually, I don't need to put that there if I'm being honest. Make that public for a second. Think about this. Nope, I don't need to put that there. I can make that back to private. I'm just going to erase that. Okay, so we're going to come down here again. That looks good. Yep, that all checks out. Okay. So now we got some movement. Now we're coming down here and we're going to say nav mesh agent .transform.local position is equal to vector3.0. And then we're going to say nav mesh agent .transform.local rotation is equal to quaternion identity. And you're thinking, Sebastian, why are you doing that? Isn't that kind of counterintuitive? Well, you'll see why momentarily, because we're actually going to handle our rotation 2 different ways too. It'll be like a hybrid system. So I'm going to say private void handle rotate towards targets, or handle rotation. Yeah, handle rotate towards targets is fine. So depending on what we're doing, if we're attacking, we're actually going to be rotating manually. And if we're not attacking, we're going to be rotating with the nav mesh agent. So we're going to say if performing action, we're going to rotate manually. Meaning our character will rotate with through motion or just like jolt towards our target or enemy. And else, we're pursuing our target, we're going to rotate with our nav mesh agent. This will give us pathfinding because the nav mesh agent will always be rotating in the right direction to avoid obstacles. So that gives us some brains. So up here we're going to say vector3 direction is equal to current target.transform.position minus transform.position. Then we're going to say direction.y is equal to 0. And then we're going to say direction.normalize. Well, not normalized. .normalize. There we go. We're going to say if direction is equal to vector3 dot 0, we're going to say direction is equal to transform dot forward. Okay. And then we're going to say quaternion target rotation is equal to quaternion dot look rotation and look towards the direction. So we're saying, hey, our target rotation is to rotate towards the direction of our enemy. So then we're going to say transform.rotation is equal to quaternion.slurp. So we're rotating between our current rotation and our new target rotation. And we're going to do that by a rotation speed divided by time.delta time. And I'm going to make the rotation speed variable because we don't have it. I'm going to initialize mine at 15. I find that's usually pretty good for my other project, but I may change it to 25 actually. Okay, that looks fantastic. Save that. Now on for the alternative rotation. So when we're actually chasing our enemy, we're going to be rotating with our nav mesh agent. So vector3 relative direction is equal to transform.inverse transform direction. If you don't know what that does, I suggest you take a look at it in the documentation. It's pretty straightforward. Then we're going to pass our nav mesh agent desired velocity. Then we're going to say vector3 target velocity is equal to rigid body, which we don't have set up yet. Okay, so let's set that up now. Let's actually put that on our Locomotion Manager. That would make more sense. So we're going to say rigid body, or enemy rigid body rather is what I'm going to call it. Let's say enemy rigid body is equal to get component rigid body. Now we'll say enemy rigid body dot velocity. There we go. Come in here. We'll say nav mesh agent dot enabled equals true because we're going to disable it if we're not using it. Nav mesh agent dot set destination current target dot transform dot position. Then we're going to say enemy rigid body dot velocity is equal to target velocity. Transform dot rotation is equal to quaternion dot slurp between our transform dot rotation, not position, whoops, and our nav mesh agent dot transform dot rotation. So our nav mesh agent, we're going to do that by rotation speed divided by time at delta time. See, our nav mesh agent is always rotating towards the direction that is the correct path for pathfinding. So, I mean, if you have an obstacle, your nav mesh agent will actually rotate to go around the obstacle. It has like a mind of its own. And if we were rotating manually, we obviously wouldn't do that. We'd be caught into a wall, and we have our enemy walking at a wall infinitely. We don't want that. But we also want our enemy to have its own rotation when it's doing any kind of root motion attack, or if it follows you off a ledge so it can jump off a cliff. So we want to use a hybrid system that uses both the nav mesh agent and just a more brainless agent as well. So we're using a combination of both, and I think that's almost exactly what Dark Souls does, if not something very similar. Why am I typing this again? I actually don't think I need this, because I believe I have it up here. Yes, I do. Okay. Sorry, guys, I'm a little bit absent-minded today. It's kind of late. I'm getting around to record this later in the day. Okay, handle rotate towards target. It's very important that you put handle rotate towards target before you put the reset of the nav mesh agent, because if not, the nav mesh agent rotation will always be 0. So you'll have your characters walking into a wall. I'm going to unfreeze my positions here on X, Y, and Z. I'm going to come in here to the Animation Manager, and I'm going to say on awake, anim is equal to get component animator. And if you guys don't know where the anim variable is, it's on our derived class, the Animator Manager. Okay, so let's actually bake some NetMesh. And if I click bake, nothing happens because nothing in my scene is static. So if you guys don't know, you have to make stuff static. Click on my construct, tap static, yes, change everything. So now since all these objects are static, I can bake, and boom, there we go. We have a situation happening here. So let's go into the Animator Manager. We're going to say on animator move. So every time this animator moves to a different animation state, like an animation, we're going to say it's going to run this code. And we're going to say float delta is equal to time dot delta time. And we're going to say Locomotion Manager. We'll call that there. And then we're going to call that awake. And that is equal to get component parent. Locomotion Manager. And then we will say right below this, Locomotion Manager. I gotta make that rigid body public. There we go. Rigid body dot drags equals 0. Vector 3 delta position is equal to animator or anim, sorry, not animator, dot delta position. Then we're going to say delta position dot y is equal to 0. And we're going to say vector 3 velocity is equal to delta position divided by delta. And then lastly, we're going to say Locomotion Manager dot rigid body dot velocity is equal to velocity times, and you can do Locomotion Manager dot movement speed if you want. But you know what? Honestly, I'm just gonna not make a movement speed variable right now. It's just fine as it is. Let's save that. And what that does is every time our animator plays an animation with root motion, it just recenters our model back on the game object because the animator's position itself moves when we actually move with animation. On start here, we're going to say NavMesh agent enabled equals false, and enemy rigid body dot is kinematic equals false. And that's on our start on enemy Locomotion Manager. And we're almost done. So I'm going to come down here and say else. This is on the handle move to target. If our stopping distance is less than or equal to, or distance from target is less than or equal to stopping distance, then we actually want to stop our player. So let's make our vertical movement 0. And this is normally where we do an attack. And we'll cover that in the next video. So I'm actually going to change the stopping distance to 1. I'll do that in here too, because I think I've changed the inspector. Yes, I do. Now we should be good to go, I believe. So let's change our rotation speed to 25 and go in game and test this out. And if I run over here to the enemy, yeah, he sees me and there he is. He's following me and there he stops. Cool, I never get sick of that. Okay, go. He's going to follow me around and he's going to stop. There we go. Excellent. We have a guy following us around. That's pretty neat. So in the next video, we're actually going to make this guy attack us. So what he's going to do is he's going to come over to us. He's within attacking range. He's going to attempt to attack us. And then we're going to cover attacks based on how far he is, the angle he sees us from. So if we're actually to the side of him, maybe he could swing at us from the side, like shield bash us. If we're far away, he could jump at us, etc., etc. We can do all kinds of cool stuff with this. We're actually going to make a function too to pick a random attack. Oh, before I go to, look at this. If we move the structure here and make a block, so to speak, and rebake our nav mesh, if I run around this structure, because our rotation kicks in with nav mesh agent, he'll actually pathfind around the structure. So I'll show you what I mean. We go out here, he sees us. Okay, let's run around these blocks, and look at that, he will chase us around the blocks. That's pretty cool. Alright guys, if you like this video, please don't forget to drop a like. It does help appease the YouTube algorithm gods. And if you're feeling super generous, leave me a comment. And if you're feeling like a total freaking champion, check out my Patreon below. It is very much appreciated. Thank you guys for tuning in, and I will see you in the next one. Bye.